It's hard to imagine a world without cell phones and iPods, or even basic electricity. But before these things were around, people spent a lot more time looking up at the night sky and contemplating the heavens. The great physicist and mathematician Erwin Schrödinger once said that the task is not so much to see what no one has yet seen, but to think what nobody has yet thought about that which everybody sees. The moon, being the most visible object in the night sky, was certainly something that everyone could see. Now, given the fact that so many people throughout history watched the moon every night, its observers began to notice patterns in its behavior. One observation that was made was that the shape of the moon and its position in the sky changed regularly according to a cycle that lasts about 29.5 days. The explanation of these phases is actually quite simple. The moon is a sphere, and at all times the side that faces the sun is illuminated, and the side that faces away from the sun is dark. The moon produces no light of its own. It is only lit up because the sun's light is reflecting off of it. You can see that the phase of the moon that we see from Earth, as the moon revolves around us, depends on the relative orientation of the sun, moon, and Earth. When the moon is almost exactly between the Earth and sun, the dark side of the moon faces us. We call this new moon. A few days earlier or later, we see a sliver of the lighted side of the moon and call this a crescent. As the month wears on, the crescent gets bigger until half the disk of the moon is illuminated. We sometimes call this half moon. However, since this occurs 1/4 of the way through the cycle of phases, the situation is also called a first quarter moon. When over half of the moon's disk is visible, we have a gibbous phase. When the moon is on the opposite side of the Earth from the sun, the entire face of the moon is illuminated. This is a full moon. A few days later, the moon is noticeably in a gibbous phase again, and soon thereafter, we see a half moon again, called the third quarter this time. Then we go back to a crescent phase, and new moon again. The cycle then repeats. When the amount of illuminated moon is increasing from day to day, the moon is said to be waxing. So from new moon to full moon, we have waxing crescent and gibbous phases. When it is decreasing, after full moon until the next new moon, the phases are said to be waning. The phases of the moon were convenient worldwide cycles that everyone could see, and thus they became the basis of determining time, and ultimately in the construction of a calendar. The Babylonians and ancient Israel, Greece, and Rome all used lunar calendars. The Muslim world, with a literal obedience to the words of the Prophet Muhammad and to the dictates of the Holy Quran, continues to live by the cycles of the moon. As I said before, these lunar cycles were pretty good at predicting time. However, they were not that good at predicting weather changes and temperature changes. What hunters and farmers really needed was a calendar based on the seasons, a way to tell when the rain would come and when the first frost would be. They got those answers with the development of the solar calendar, since seasons were dependent upon the motion of the Earth around the sun and its relative position as opposed to the moon revolving around the Earth. The first thing that you will need to do is to find a clear, flat area to perform your observation. You should have a clear view of the entire sky with only a few landmarks present to be used as reference points. Make sure these landmarks are near the horizon. Try to stay away from any brightly lit areas, and wherever you choose to make your observation, be sure to come back and stand in exactly the same spot for subsequent observations. You also need to be sure to make your observations at the exact same time each night, within 15 minutes, to be sure your results are accurate. Try to observe at least every other night for a period of about 2 weeks. You thus are not observing the entire lunar cycle, only about half of it. But that should be enough to deduce the patterns in this exercise. In order to plan when you will start this exercise, you may want to check for lunar cycle dates. You can search for this on the internet, but you can also find these dates on most household calendars. Pick a date to start that corresponds to one of the main steps of the cycle, such as the full or quarter moon, though any phase besides the new moon would really do, so long as you know where you are starting. In order to record your observations, you will need to make a scale drawing of the observation area, including all of its landmarks. The landmarks will be important in keeping track of the position of the moon in the sky as it moves between each observation period. To make a scale drawing, you will need to measure the height, width, and separations of a few landmarks around your observing site. Perhaps the easiest way is to use a ruler to measure the dimensions and separations of landmarks, with the ruler held at arm's length. In this case, a convenient scale to use is 2 centimeters on the ruler, corresponding to 1 centimeter on the drawing. Once you have an accurate downsized view of your observation field, you will need to plot on your drawing a position of the moon on your first day of observation. To do this, you will need to make 2 measurements. Choose a convenient landmark near the moon, and from a particular point on the landmark, measure how far over and how far up the moon's center is located. Record the appearance of the moon at the plotted position. You may want to forget about getting the moon's size to scale and use any conveniently sized object like a coin to draw in the moon and indicate how much of it is lit up. In other words, what it looks like. You should also record the positions of a few bright stars near the moon on your first observing session. Number your observations of the moon, and in a corner of your drawing, record the date and time to the nearest minute of each observation. Also, determine the direction of 1 or 2 compass points, such as west and south, and indicate them on your drawing. The purpose of this laboratory exercise is for you to make some of the same observations as did people of the ancient times. Taking about 6 observations over a 2-week interval, you should see how the moon changes position in the sky and how its appearance changes as it moves. Be very careful with your drawings to make sure that your data is accurate, and also be sure to answer all questions in the laboratory procedure.